In this lesson, we will look at a situational problem that involves both the primary trig ratios as well as the sine and cosine laws. Daniel is trying to estimate the height of a new building that has just been built in Moose Jaw, Saskatchewan. From where he is standing, he estimates the angle of elevation to the top of the building to be about 80 degrees. He then walks 50 meters further away from the building, and from this position estimates the angle of elevation to the top of the building to be about 60 degrees. If Daniel's estimations are correct, how tall is the building? So based on this diagram, he's standing at this point and believes that his angle of elevation is 80 degrees. Then he backs up to point A, which is 50 meters away, and believes that his angle of elevation is 60 degrees. So he wants to use these two angles to calculate the height of the building. So this is going to be a two-step problem. We are going to calculate a couple of the angles, and then we're going to calculate the side length for B. Once we're finished that, then we can use our primary trig ratios with a 90-degree angle that is formed by the building and the ground to find the height of the building. So in this triangle that has a 60-degree angle, we can calculate the other two angles. So where he's standing right now is a straight line, which is 180 degrees. And this is made up of two angles, so the 80 degrees and then the other one. So if I take the 180 degrees and subtract 80, this angle in here will be 100 degrees. Now in the triangle A to where the person is standing up to C, we can use the 180 degree method. So 180 degrees minus 100 minus the 60. So 180 minus 100 is 80, and then 80 minus 60 will give us 20. So this angle right here is 20 degrees. So now we can use the sine law to figure out side B. So we will have B over sine 100. And this will equal 50 meters over sine 20. So now we want to calculate sine 100 and sine 20. So we will get B over 0.9848. And this will equal 50 over sine 20, which is 0.3420. So now we'll cross multiply. So we'll have B times 0.3420. And this will equal the other two multiplied together. So 50 times 0.9848 is 49.24. Now we're going to divide out that 0.3420. And our B value will be 143.97. So we'll round that up to 144 meters. So that gives us side B. And this will help us to find the height of the building. So now we know that we have a right triangle from the building across the ground and up to the top of the building. So there's our right triangle. And because we have a right triangle, we can use our primary trig ratios. So I'm going to use the sine ratio because I know I have a 60-degree angle and sine is the opposite side, which would be the building, over the hypotenuse, which would be 144 degrees. So this is our opposite side and our hypotenuse. So we're going to have sine of 60 degrees equals the opposite side over the hypotenuse. So the opposite side is the height of the building, so that's what we're looking for. I'm going to call that x. Over the hypotenuse, which is what we just calculated, as 144 degrees. So I'm going to calculate sine of 60, which is 0.8660, and this will equal x over 144. And now I'm going to cross multiply. So x times 1 is just x. And then I'll multiply the other two together. And when I do that, we'll get to 124.7 meters. So the height of the building is 124.7 meters tall.